Hello and welcome to the channel Engineering Time Capsule. Today we're taking a journey through history of mathematics, where we will learn about the fascinating Pythagorean theorem. Let's get started. In the system of Greek numerals, alpha, beta and gamma represented values of 1, 2 and 3 respectively. Alpha meant ox, beta a house, and gamma probably the throwing stick. Alpha, beta and gamma are commonly used as names for the inner angles of a right triangle. Next, let's dive into some interesting etymology. Here are the meanings of right triangle sides. The term hypotenuse comes from the ancient Greek meaning stretching or extending, while cathetus meaning perpendicular, vertical, or orthogonal. These words perfectly describe their roles in a right triangle. Cathetus is also called a leg of the right triangle. We'll validate the Pythagorean theorem with a simple experiment using paper. By creating squares on each side of a right-angled triangle, we can visually and intuitively understand that the area of the squares on the legs of a triangle equals the area of the square on the hypotenuse. We can also interpret this as 2D pools colored blue and violet, and the area of those two pools is equal to the area of the bigger yellow pool. I hope you now understand that formula from elementary school saying that the a squared plus b squared is equal to the c squared. See how the pieces fit perfectly. This not only proves Pythagoras' theorem, but also makes it easy to grasp. Now let's travel back to ancient Egypt. Egyptians believed that the most significant thing you could do is prove the Pythagoras theorem. Egyptians used ropes with knots at equidistant intervals. This equidistant is just meaning that they were equally placed between one another. So they placed those knots to form right triangles, either by stretching it and holding it by hand, or by using wooden sticks placed in the ground. Therefore, that is the reason why we got the words for hypotenuse and cathetus, because of these ropes and knots. The most popular right triangle is 3, 4, 5 triangle. By creating a triangle with sides of 3, 4 and 5 units, they could accurately measure right angles. It was a technique essential for constructing their architectural marvels. Speaking of the 3, 4, 5 triangle, did you know what was the area of the circle inscribed within the right triangle? Let's use simple math to find out. So first, we need to find the center of the circle and draw lines from the center to where the circle touches the tangent lines, or the legs of the right triangle. So these lines make a square because they form right angles within the tangent lines, meaning that those 4 sides are all r's. Given that one side of the square is r and the total length is 3, the remaining part is 3 minus r. The same logic applies to the other side, where the total length is 4, so the remaining part is 4 minus r. At the intersection of the tangent lines, the distances from the intersection to the points where the tangents touch the circle are the same. This makes both segments 3 minus r and 4 minus r. To find the r, we need to set up this equation, and from it we see that the r is equal to 1, which gives us finally the area of the inscribed circle being pi. Thanks for watching. Don't forget to like, share and subscribe, and hit the bell button for more math tutorials. See you next time.